Good evening, everybody. We're talking about simplifying rational expressions tonight in section 7.3. So what is a rational expression? Well, remember we talked about it's a fraction with a polynomial. So x is a polynomial, 1 over x is a rational expression. X over 3x minus 7 is a rational expression. So anything that would look similar to these. They are also fractions. So we're going to go back and start talking about simplifying regular fractions. What would I do to reduce 42 and 124? Well, we would try to reduce it by taking out common factors. So they're both even. Let's divide it by 2. We have 21 over 62. Can we reduce this further? 21 is 7 times 3. Can I divide 62 by 7 or 3? I don't think so. So this would be simplest form. Let's try that with rational expressions. 16x and 24. Well, the x is there. There's nothing we can reduce that with. But 16 and 24 have a common factor of 8. So if I divide 16 by 8, we get 2 with the x, and 24 divided by 8 is 3. That would be simplest form. Let's talk about this next one, x minus 7 and x squared minus 7. So probably the first thing we want to say is, oh, those are the same, so I can reduce those, and then I can reduce an x from the top and the bottom here, so I'd be left with 1 over x. However, that's not the case. I'm not allowed to do that. These 7s are attached by the subtraction. So the only way that I could simplify these is if I can factor. Remember, when we're factoring, the very first thing we check for is a greatest common factor, and then we look at our other methods of factoring to see if they work. On the top part here, x minus 7, there is no common factor besides 1, so there's nothing I can pull out to reduce it. On the bottom, we have x squared minus 7. So two terms, subtraction, I see a square, I'm thinking difference of squares formula. But the 7 is not a perfect square. So I can't do any factoring with that. So this already is in simplest form and cannot be reduced. Let's take a look at this next one. X squared minus 36 is a difference of squares. So we'll factor that by square rooting each one, and we get x plus 6 times x minus 6. On the bottom, there is no common factor. So I'm going to look and say the factors of negative 12 that add to positive 4 are positive 6 and negative 2. Now that I've factored, remember, as long as whatever our factor is the same on the top and the bottom, the numerator and the denominator, then we can reduce it out. And these both have a factor of x plus 6. So we factor out that x plus 6, and that would make our simplest form x minus 6 over x minus 2. Remember, we can't reduce the 6 and the 2 or the x's because they're grouped together with the subtraction signs. All right, we're going to skip this first example and come to example number 2. So on the top, we're factoring out the greatest common factor, which is 3x. That leaves us with 6x minus 1. On the bottom, there is no common factor, so 6 times 1 is 6. The factors of positive 6 that add to negative 7 are negative 6 and negative 1. So I'm going to do our factoring. Remember, we split that in half. Take the common factor on the left side, which is 6x. When we pull that out, we're left with x minus 1. The right side starts with that subtraction. And when we factor by grouping, we always have to take a factor out. And so our common factor over here is 1. Dividing those by negative 1 gives us a positive x and a negative 1. Remember, we're looking for these two parentheses to be the same to know that we have factored correctly and that we can factor further. And so x minus 1 is one of our factors, and we pulled out 6x minus 1. And then we have that 3x and 6x minus 1 on the top. So I look, and that 6x minus 1 is common for the numerator and the denominator. And our simplest form would then be 3x over x minus 1. Okay. Number 3. On the top, we're going to start with our greatest common factor again. Our greatest common factor on the top is 4x. When I pull that out, it leaves us with x squared minus 4x plus 3. That is still factorable. So we'll say the factors of positive 3 that add to negative 4 are negative 3 and negative 1. So we have the 4x that we pulled out, x minus 3, and x minus 1. On the bottom, common factor is going to be 4x. And I'm actually going to pull out a negative 4x. So that way we can have 12 divided by negative 4 is negative 3. Negative 4x squared divided by negative 4 is positive x. So when I rewrite that, I want that x to be first. And we're going to put x minus 3. So the x minus 3's are common. These x's are common. And the 4's are common. So we are left with x minus 1 on the top and a negative on the bottom. That negative is really a negative 1. So we have this is our answer, which when we divide by negative 1 will look like this. Restrictions. With all of these, we have to worry about restrictions. Restrictions are numbers that make our fraction undefined. And that means the denominator will be 0, which either leads to holes in my graph or my asymptotes. So all the ways that we've already been working on finding our asymptotes from the denominators to graph is the same way that we find our restrictions. We take the bottom and only the bottom, set it equal to 0, and solve for x. So in our first example here, I look at the bottom. That's a 24. This one would have no restrictions because there's no variable in the denominator. On this next one, we'd set x minus 4 is equal to 0. So our asymptote is at positive 4, which makes our restriction positive 4. So we could pick anything we want except positive 4. 2x plus 6 can't be 0. Subtract the 6. And divide by 2. And our restriction here is negative 3. Our asymptote would be negative 3. All right, our last example, when I set that one equal to 0, I say, ooh, we have to factor because there's x squared and x and then our constant. So is there a greatest common factor on the bottom we can pull out? No. The factors of negative 6 that add to negative 5 are negative 6 and positive 1. So our factors would be x minus 6 and x plus 1. Remember that we want to set each of those equal to 0. So x can't equal 6 or negative 1. So the last thing with simplifying rational expressions is this caution. You always have to find the restrictions before you simplify the problem. You have to find the restrictions before you simplify the problem. Cannot cross anything off until you get the restrictions. So I'm going to start with factoring. Always want to start with factoring. On the top or the numerator, we have a common factor of 6. When I pull that out, I'm left with x minus 4. X minus 4 cannot be factored further. On the bottom, starting with a common factor, it's x, leaves us with x minus 4. That also cannot be factored any further. Now, I see that I'm going to cross off those x minus 4s, but before I can do that, I have to find my restrictions. Every single x in the denominator has to be set equal to 0 and solved for. So this x gets set equal to 0, and this x gets set equal to 0. This first one is already solved, so one of our restrictions is 0. For the second one, I'm going to add 4, and our second restriction is x cannot be 4. Now that I've found my restrictions, I can reduce my x minus 4s, and so my final answer is 6 over x, where x cannot be 0 or 4. All right, the second example, x squared minus 36. Is there a common factor that I can reduce by? No. So can I factor this? Yes. It's the difference of squares. We have x plus 6 and x minus 6. On the bottom, is there a common factor we can reduce the whole thing by? There is not. So we need the factors of negative 12 that add to positive 4, which are positive 6 and negative 2. Again, every single x has to be solved for your restriction in the denominator only. So this x can't be negative 6, and this one is positive 2. So our restrictions, or our asymptotes, are at negative 6 and positive 2. Now I can reduce. The x plus 6's can simplify out, and so we're left with x minus 6 over x minus 2 with restrictions at negative 6 and positive 2. This is where we're going to stop for now. See you tomorrow.